Hello, this is Prep for Calc exam review for spring 2023, part 4. We are going over continuing this section from the last video. So question 29, true or false? If a function f is decreasing and its graph is concave up, then the rates of change of f are negative and they're getting larger when moving from left to right along the graph. So this is true, and let's think about why. So what does it mean for f to be concave up? Well, it means that, basically, I'm going to draw a little picture here. Our go-to for concave up should always be a parabola with a positive, like a positive x squared term. So it's concave up, meaning that if we're over here and we draw a secant line, that's a bad secant line. Allow me to redo that real fast. Draw a secant line. A bit of a messy picture, but the secant line has a negative slope. But as we move, say, over here, the slope is increased to be positive, right? So the idea is that although the rate of change may begin negative, it is increasing to be positive, and that means that it's concave up. So that's kind of what the concavity suggests. So even if the rates of change are negative, as long as they're getting larger as we move from left to right, then we're concave up. So this would be true. For 30, we want to give an example of a function h that has a domain from -6 to -1, from -1 to 5, and from 5 to infinity, not including -1 or 5. So what we can do is define f of x to be, allow me to, I'll leave the f, it's all messy, but, so we don't want anything past -6. So what we can do is take a square root function, for instance, and shift it to the left by 6. So we're going to take square root x plus 6. What this does is it takes our square root function, which is only defined over positive numbers, and it moves it to the left by 6. So we're defined now at -6. Now I'm going to add two other things. I want to be not undefined at -1 and undefined at 5. So what I'm going to do here is I'm going to add vertical asymptotes. Basically, when we want something to be undefined, we can think about taking the square root of a negative number, taking log of a negative number, or dividing by 0. And the easiest thing to do for these singular points is to divide by 0. So what I'm going to do is if I want it to be 0 for -1, I'm going to say x plus 1 in the denominator, and I'm going to say x minus 5 in the denominator. I'm going to rewrite this function for visibility. Root x plus 6 over x plus 1, x minus 5. Beautiful. Okay, so that's good for 30. For 31, we want to know what the domain of g of x equals root x minus a over x plus b is, where a is greater than 0 and b is greater than a. We want to write it in interval notation. So kind of going from 30, kind of the reverse, when we have a function shifted by, and when we have a square root function shifted, we know that for the square root to be defined in the real numbers, x minus a has to be greater than 0. So x has to be greater than a. But it can be 0, right? The square root can be 0. And b is not equal to a, so we're going to start at closed a. Our interval starts at a, and then we go to b. Because b is greater than a, b is going to be on the right side of the interval. And then we're going to include the open interval at b to infinity. So the important thing here is that we don't include b, and we don't include anything strictly less than a. So we can include a because that makes g 0, but we can't include anything less than a because then we would have the square root of a negative number, so we would be imaginary, right? So this is our interval. This is a union symbol. Square bracket means we're including a. Parentheses around b means we're including everything except for b. Okay. So for question 32, a function f has the average rate of change as shown in the table, and it is either concave up or concave down in its entire domain. So the average rate of change of f is negative, but is increasing. So as we go from left to right, so from -2 to 0, it's -1.5, but from 0 to 2, it's -0.38, and it's increasing as we move to the right, which means it is concave up. So we can actually get rid of option C. So which leaves option A and B. From the picture, we know that they're concave up, but we don't know which one it is. So let's think a minute, right? Look at A, and start drawing little secant lines, right? They have a positive slope. The secant lines over the intervals we care about, for instance from 2 to 4, all have positive slope. So we can actually get rid of A as well. Because the average rate of change given in the table, they're all negative. So we're actually going to pick B. And the explanation would just be average rates of change are negative but increasing, so it's concave up. And then A and B are the only concave up graphs, but A has positive rates of change, so we can get rid of A. So for question 33, the graph of a function f is concave down and decreasing. Which average rate of change must be greater? Explain. So A is the average rate of change in the interval from -3 to 0, and B is the average rate of change in the interval from 0 to 5. The graph of a function f is concave down and decreasing. Let's draw a graph that is concave down and decreasing. Go to upside down U, concave down. So when it's concave down, as we move to the right, when we're concave up, as we move to the right, our rate of change is increasing. When we're concave down, as we move to the right, our rate of change is decreasing. So the average rate of change in the interval from 0 to 5 would have to be less than the average rate of change in the interval from 0 to in part A, which is from -3 to 0. Because we've moved to the right, our average rate of change must have decreased. So the answer is A. And right, the idea is of concavity is that it's concave down. So if we're decreasing and we move to the right, we'll be decreasing more than we were. So let's move to the next page. Question 34. Which of the following possible equations for the parabola is shown? So let's talk about B first. I'm going to start with B. So B tells us that we have a repeated root at P. But in this graph, we have a root at Q, a root at R, and a vertex and a y-intercept at P. So we can cross out B, because we don't have a repeated root and we don't have a root at P. At C, we have a repeated root at Q, so we can throw that out. Because again, we have one root at Q, one root at R. For D, it says that we have a repeated root at -Q. That's also incorrect. We have one root at Q and one root at R. E says that we have a root at Q and a root at R. That's true. So I'll circle E. A says we can rewrite this as P minus X squared or X minus root P, X plus root P. This is possible if Q is equal to root P and R is equal to root P. Okay, so now on to 35. Suppose a quadratic function of the form f of x equals a x minus h all squared plus k intersects the x-axis exactly one time. Explain what is true about the values of a, h, and k. So I think it's important to think about this as it's in vertex form. What does a vertex mean? So we have to intersect the x-axis once. What are the ways that happen? How do we intersect the x-axis? Well, if I just draw a parabola over here, doesn't intersect at all, right? But if I shift it down, same parabola, shift it down, so I have a negative k. Now I intersect twice, right? So what do we know about k? For it to only intersect once, well, k has to be 0. Our vertex has to occur on the x-axis. Okay, great. What else do we know? That is actually our only constraint. A is going to tell us whether it's positive or negative. So this would be negative A, positive A. And then H is going to tell us where on the x-axis it intersects. But the only constraint is that K is equal to 0. So now for 36, we're told that each of the four functions shown can be written in the forms y equals ab to the x and y equals ae to the kx for each. We want to determine whether a and k are positive or negative, and whether b is between 0 and 1 or greater than 1. So I think it's helpful when looking at functions of this, like when we're given a graph and we want to match the graph to, signs or values of parameters in the function, it's best to think about our parent function. So just go over here and draw a normal exponential function. The important thing is to recognize that if b is negative instead of positive, it's equivalent to reflecting across the y-axis. And so instead, we'd end up with this function, right? So from this, I'm going to say that f has a b less than 0. I'm just going to use I'm going to use a check mark. I think that'd be better. So y, f has a b less than 0. Mistake. Right. K less than 0. So a being positive or negative, back to this picture over here, corresponds to reflection across the x-axis. So for both f and g, a is positive. For h and k, a is negative because they're down here, and f and j are up here. F and g are up here. So a is negative for h and k, a is positive for f and g. K is less than 0 for f because, like we talked about, if k is negative or if b is negative, we've reflected across from our parent graph. And so as x increases, we're decreasing. We can kind of see this behavior over here. So f has a negative k, as does, let's see. So if I reflect, we can actually match h to this reflection we just did over here. So it would have a negative a, but still a positive b, and a positive, or rather a positive k. So I'm going to put h here. I'm going to go back to b in a moment. B is never negative. It's whether or not it's less than 1. So I misspoke. K is negative. B depends on whether it's less than 1 or not. So f would have a b less than 1 because, again, it's decreasing. G would have a b greater than 1. And an a greater than 0. And then k would have a... It would be reflected across the x-axis and then across the y-axis. So it would have a k less than 0 and a b less than 1, and h would have a b greater than 1. So that's kind of how we go about this, is look at the parent graph and then match how does a transformation in the parent graph correspond to these inequalities in the parameters. Great. So that is our Prep for Calc Math 1813 review. Please let us know if you have any questions, and feel free to come to the MLSC with any review questions.